This is Module 4, Lesson 4. We're still solving multi-step linear equations. Remember, we're trying to make sure that we use whatever we need to, distributive property, collecting like terms, and solve equations to get the solution. So today we're going to be solving multi-step linear equations again. This is from Eureka Workbook, Module 4, Lesson 3. This is on page 19 in that workbook. The first question says, is the equation a true statement when x is equal to -3? In other words, is -3 a solution to the equation 6x plus 5 is equal to 5x plus 8 plus 2x? Explain. Well, we're going to explain by actually solving the equation and seeing if -3 is a solution. Another way would be to plug -3 in and see if it works, but we're going to solve it. We've got 6x plus 5. We're going to see if it's equal to 5x plus 8 plus 2x when x is -3. First, let's solve the equation. Let's look at this expression on this side of the equal sign. Is this as simple as it gets? I have a variable here, and then I have numbers here with a coefficient. So this is as simple as it gets. Is this as simple as it gets? No, because I can combine these like terms. I have 5x's and 2x's. I can combine that together to get a total of 7x's. 7x plus 8 is equal to 6x plus 5. Okay? Now, guys, let's see what we can do to solve for x. On this side, I've got 7x. On this side, I've got 6x. What if I collect all the variables over here and all the numbers over here? To get the 7x away from this side, I do the opposite of what's done. If there's a positive 7x, I would say -7x. And I do what I do on one side of the equal sign, I do on both. Now, this 7x is gone, because 7x minus 7x is 0. That leaves me just 8 over here. 6x minus 7x gives me -1x. And let's bring down this plus 5. We're trying to solve for the x. I need all the numbers over here and the variables here. There's a 5 added to this. The opposite of adding a 5 is to subtract a 5. What I do to one side of an equal sign, I do to both. Okay? So this is gone. I have -1x is equal to 3. Now, what do I need to do? Let's divide both sides by -1. And x is equal to -3. Okay? What did we ask whether or not it was the answer? Is the solution -3? Yes, it is. How do I know that? I've solved it for x, and x is equal to -3. Okay? Now, we're going to skip the second one because I'm not dealing with fractions where you're going to need to find the common denominator. So let's go to number 3. I don't think that will necessarily be what we need to do to prepare for this. So let's go to number 3, and I'll move it up here so we can work it. Chad solved the equation 24x plus 4 plus 2x equals 3 times 10x minus 1, and is claiming that x is 2 makes the equation true. Is Chad correct? Explain. Let's move this up here. 24x plus 4 plus 2x. Is that equal to 3 times 10x minus 1 when x is -2? I could plug, or when x is 2, I could plug 2 in, or I can solve for x. I'm going to solve for x. Let's look at this. Is this expression as simple as it can get? No, I can combine these like terms. 24x plus 2x gives me 26x plus 4 is equal to, okay, now this is distributive property, so let's distribute this. 3 times 10 is 30x. 3 times -1 is -3. Okay? Now, what I need to do is I need to make sure that I collect like terms. I need all the variables over here, all the numbers over here. Let's subtract 30x from both sides. When I subtract 30x from both sides, I've got -4x plus 4 is equal to -3. Okay, now let's subtract 4 from each side. I now have negative 4x equals negative 7. Let's divide both sides by negative 4. And I get x is equal to negative 7 over negative 4. A negative divided by a negative is a positive. X is equal to 7/4. That is not 2. Therefore, this is not correct. 2 is not the solution. So Chad is incorrect. How do I know? Because the solution is actually x is equal to 7/4. Please to solve this equation. X plus 6 is equal to 8 plus 7x. And claim the solution is x is equal to negative 3. Is she correct? Explain. Well, let's try it and see. Okay. In this case, this is as simple as it gets. This expression is as simple as it gets. I want to get all the variables over here and all the numbers over there. So what if I subtract 7x from both sides? This is 1x. Okay, 1x minus 7x would give me negative 6x plus 6 is equal to 8, right? Because 7x minus 7x is 0. Let's subtract 6 from both sides. And negative 6x is equal to 2. Let's divide both sides by negative 6. And x is equal to negative 1/3. Okay? So x is negative 1/3. Okay? That's exactly what we asked what the solution would be. She is correct. How do we know? We've solved the equation, and the answer is x is negative 1/3. Okay? Now, I want to go down to, let's see, we've got 5 here. I want to go to 6, actually. Claire was able to verify that x equals 3 was the solution to her teacher's linear equation, but the equation got erased from the board. What might the equation have been? Identify as many equations as you can for the solution of x equals 3. Well, let me ask you guys, could 5 minus 2 equal x if x is 3? Yes. How about 2 times x is equal to 6? Anything where x is 3, this would work. Does an equation always have a solution? No. Can you come up with one that doesn't? Okay, now let's look into that a little bit. And we're going to look at this. Okay, this shows it to us right here. If you've got an equation is a statement about equality between two expressions. If the expression on the left of the equal sign has the same value as the expression on the right, then you have a true equation. A solution of a linear equation in x is a number such that when all instances of x are replaced with the number, the left side will equal the right side. For example, 2 is the solution for this equation here. If I plug in 2, the left side is going to be 10, the right side would be 10. Since 10 is equal to 10, x is a solution to this equation, okay? Let's talk about when we have no solutions, okay? And when we have many solutions. Let's look first at many solutions. Let's solve the problem we've got here. If you've got 2x plus 7 is 27 and 3x plus 1 is 28, will these two be equal to each other? Let's write them together so you can see it. 2x plus 7 equals 27. 3x plus 1 is equal to 28. Well, these two numbers are not equal, so it makes sense that this cannot be equal to that, okay? Is negative 5 a solution to this equation? Well, I can plug it in, or I can solve for negative 5. Either way would work. Okay, let's see. 6x plus 5, is it equal to 5x plus 8 plus 2x? Okay, I'm going to solve and see if I get it equal to negative 5. This expression is as simple as it gets, but here I can collect like terms. So I've got 6x plus 5 is equal to 7x plus 8. Okay? I want all the variables on one, all the numbers on the other side. I'm going to subtract 7x from each side. When I do that, I have negative 1x plus 5 is equal to 8. I'm going to subtract 5 from each side, and negative 1x is equal to 3. I'm going to divide both sides by negative 1, and x is negative 3. Okay? It asks me, is negative 5 a solution? No, because x is just negative 3, correct? Okay. We're going to skip 3. Let's go to 4, and I'm going to erase this so we've got some room to work here. Use the linear equation 3 times. Let's fix this up here. 3 times x plus 1 is equal to 3x plus 3. Does 5 satisfy it? Let's plug it in and see. 3 times 5 plus 1 is equal to 3 times 5 plus 3. That'd be 3 times 6 is equal to, which is 18, is equal to 15 plus 3, which is 18. So yeah, that one does work. We've done the work right here. We've plugged it in, it works. Let's see if x equals negative 8 is a solution. Let's plug that one in, okay? I'm going to get it right here where we were. Is negative 8 a solution? Let's plug it in and see if it works. Is 3 times negative 8 plus 1 equal to 3 times negative 8 plus 3? Well, let's take care of what's in parentheses first. Negative 8 plus 1 is negative 7. And let's see, that's negative 21. 8 times negative 3, 3 times negative 8 is negative 24. Plus 3 is equal to negative 21. Okay? Those are equal. So hence negative 8 is a solution. Yes. Explain. It works. We've shown you the thing. Is 1/2 a solution of the equation above? Well, let's try it and see. Is 3 times 1/2 plus 1 equal to 3 times 1/2 plus 3? That's 3 times 1 1/2. Is that equal to 3/2 plus 3? Let's see. 3 times 1 1/2, that's 3 and 3/2, which would be 4 and 1/2. And this is 4 and 1/2. Those two are equal. So yes, this is the solution. What interesting fact about this equation is illuminated? What do we learn? No matter what I put in, the two sides are equal. All of the things that we've come up with are solutions. Okay? Everything seems to be a solution no matter what I'm putting in. Let me show you something real quick. If that's the case, it's going to look exactly alike whenever I work it out. 3 times x plus 1. Is that equal to 3x plus 3? Let's use the distributive property here. That's going to give me 3x plus 3 is equal to 3x plus 3. If I work something out and the expression on this side is exactly like this one, then anything can be the solution. Anything, any answer that you put in there will be a solution for this. In fact, if I subtract 3x from both sides, it's simply going to give me that 3 is equal to 3. And this tells me, when I get to the bottom of the equation, if all I've got is this tells me that anything could be a solution to this particular equation.